Okay, we're going to look at how we find the inverse of a 3 by 3 matrix. It's a 5-step process, and the first step is finding the determinant. So how you find the determinant of a 3 by 3 matrix is by reducing 3 by 3 determinant to 2 by 2 determinants using this formula here. Now this looks very confusing, but it really is not at all. Okay, forget about these determinants here at the minute, and notice you've got A, which is your first row, first column element. You've got minus B, which is a negative of the first row, second column element. And then you've got plus C, which is a first row, third column element. How we get these bits in, this is a tricky bit. So the only hard bit about the first thing is remembering it's positive, then the negative, and then the positive of the elements in the first row. Then how you get these things. Let's look at the one for A. Take your A and cross out the row and column containing the A, and then what you're left with, you'll notice is what is in this 2 by 2 determinant. So that's dead easy to get. So that's really how you want to do that. For the next one, take your B and cross out its row and column, and what you're left with is A, F, G, and I. And what have you got in here? Sorry, D, F, G, and I. You've got D, F, G, and I. Okay, and the last one, take your C and cross out its row and column, and what you're left with is D, E, G, and I, and that's what we've got here, D, E, G, and I. Okay, the next wee bit of notes is just really explaining that again, same sort of way, explaining how you cross out the rows and columns. So we want to look at just an example of how we would actually do this. One thing just before the example, wee reminder. As for the 2 by 2 matrices with 3 by 3 matrices, if the determinant of A is equal to 0, then A is said to be a singular matrix, and also if it's singular, remember that means there's no inverse exists. And if it's not equal to 0, then it's non-singular. Okay, we'll look at this example. So here we have to find the determinant of 1, 2, 7, 3 minus 5, 2, 1, 1, 4. So the first bit is dead easy. The first way I'd set this out, I'd say it's 1, and then times a 2 by 2 determinant, then minus 2, so that's minus of this element here, another 2 by 2 determinant, and then plus 7, so this element here, times another 2 by 2 determinant. So how we get the 2 by 2 determinants, remember, to get the first one here, we're just going to cross out the row and column, containing the 1, and you're left with 5, minus 5, 2, 1, and 4, which is what you have here, and that's it. For the next one, it's the minus 2. So you cross out, this is the 2, this one here, and you cross it out and you're left with 3, 2, 1, and 4. So the determinant of 3, 2, 1, and 4. And for our last one, you've got our 7. So where's our 7? It's here. Cross out its row and column, and you're left with this. So it's a 2 by 2 determinant of that. Okay, all you've left to do is to actually do those things out. So that is 1 times, and then it's going to be 2 by 2 determinant, minus 5 times 4 is, minus 5 times 4 is 20, and then 2 times 1 is 2, so it's minus 20 minus 2. Down here, then next one is minus 2 upon 3 times 4 is 12, and then 1 times the 2 is 2, so 12 minus 2. And 7 upon 3 times 1 is 3, and 5 times minus 5 times 1 is minus 5, so it's 3 minus minus 5, so 3 plus 5. Wee bit of working out there, you'll get the determinant of this thing is 14. We will refer back to, we're going to now find the inverse of this matrix here, and one of the steps involves finding the determinant, so bear in mind we have done the working out for this already. Okay, step 2 of this process is to find the matrix of minors. Now the matrix of minors is, what you do here is you take every element, so all 9 elements, and you cross out the row and column contained they're in, and you're left with 4 elements. So that forms a 2 by 2 matrix, and you find a determinant of that 2 by 2. So it's the same as what you did for the top row, where you crossed out the row and columns, and you found a determinant of what was left. Same idea, but you've got to do this for all 9. So if you've done your working out well for the first part of the process, you've found the top rows of these anyway. Okay, step 3 is called a matrix of cofactors, and that means you change the signs of some of the elements of the matrix of minors according to the rule of alternating signs. So the first one stays positive, the next one changes sign, the next one does not change sign, the first one changes sign, the next one doesn't change, the next one changes, the next one doesn't change, the next one changes, the next one doesn't change, the next one changes, and the last one stays the same. Step 4 is the easiest of all of them. It's you write down the transpose of the matrix of cofactors. The transpose, remember, is you change the rows to columns and vice versa. And step 5 is divide by the determinant. So that was our first thing that we did, but we had to find your determinant, but we now have to divide that. So just do 1 over your determinant. Okay, so in this question we have to find the inverse of, we need to find the inverse of this. So our matrix is A, which is 1, 2, 7, 3, minus 5, 2, 1, 1, 4. And you should notice this is the same matrix we used in the previous example where we found a determinant. So here we've introduced another notation, so we might as well highlight these. So instead of saying just the determinant of A, you could do a couple of things. Determinant or modulus of A. Remember modulus symbol from last year, so that's the same as the determinant of A. So they all mean the same thing. So if you see that wee triangle, that means the determinant, and that means the determinant of A as well. So they've used the modulus sort of version here. So that was equal to 14 from the previous example. So that was our first step. Our second step then is our matrix of minors. How we did this, remember, and I'm just going to pick out one of these to show you how we do it. So how we've arrived at this one is you take the element, that's a second row, first column. So you cross out the second row and the first column, and you do the determinant of what is left. So what is left is 2, 7, 1, and 4. So if you do that like that, it's going to be 2 times the 4 minus 7 times 1, or 8 minus 7, which is 1. So you've got to do that for all 9. Now remember, you had already done this one, you had already done this one, and you'd already done this one from the previous part of the example. So if you've set your work out well, that should save you a wee bit of time. Okay, next bit is a matrix of cofactors. Now the matrix of cofactors is dead easy. All you do for the matrix of cofactors is you change the signs in the alternating signs pattern. So what we mean by that, remember, it was first one stays the same, second one changes, the third one stays the same, next one changes, next one stays the same, next one changes, next one stays the same, next one changes, and the last one stays the same. So here, first one was minus 22, stays the same. Next one was positive 10, changes to minus 10. Next one was 8, stays. Next one changes. Next one stays the same. Next one changes. Next one stays the same. Next one changes. Next one stays the same. Okay. Next step is to transpose. So that means the rows change to the columns. The first row was minus 22, minus 10, 8. And that now becomes the first column, minus 22, minus 10, 8. The second row was minus 1, minus 3, 1. That becomes the second column, minus 1, minus 3, 1. And the last row was 39, 19, and minus 11. So 39, 19, minus 11. Done. And your last step then was divide by the determinant. Our determinant we worked out to be 14. So 1 over 14 upon this thing would be the inverse. The way you could prove that this is correct is take this thing, this whole new inverse, and multiply it by the original thing, and you should get your 3 by 3 identity. And that is how you could prove it to yourself. I would not advise doing that in the exam, but just at this stage where you're building confidence in the process, that would be worthwhile doing. Okay, you want to have a look at exercise 4b in your matrix worksheet, question 3, and then question 4, the alternate parts. Thank you.